All right, so today we're going to look at financial models. So this is what's called your compound interest formula here. And it stems from your simple interest formula. If you remember, simple interest is principal times the rate times time. So for example, if you put $100 into a savings account and you get 3% interest for 1 year, T 1 year, then your simple interest is $3, right? The bank would give you $3 back in simple interest after that 1 year, right? That's simple interest formula. Well, if you were to use that simple interest formula and you're doing it for like a compounding situation, so like maybe every 3 months the bank is giving you a little bit of interest, right? Well, then you end up with this compound interest formula. Which P is your principal, R is your rate in as a decimal, N is your compoundings, and T is your time in years. These are your compoundings. So it depends on how many compoundings you do. If you're like this scenario, we're compounding monthly, so my N will be 12. We're putting this $300 in for 1.5 years, so we got 1.5 for our time. And $300 is how much we're putting in up front. That's the principal amount up front. R is 12%. Well, 12%, that's per cent. In other words, per 100%. So 12% is 0.12. You want to use this as a decimal. So make sure you change that percent to a decimal. 12%, 0.12. Now let's go ahead and see how much money you have. You put in $300. You just let it sit there for 1.5 years at 12% compounded monthly. So our N is 12. And we're going to punch this in. So first thing is I'm going to do 0.12 divided by 12 in my calculator. So that'll give me 0.01. And I need to figure out 12 times 3.5. That's 18. 12 times 3 halves is 18. And I'm working from the inside out, right? So the first thing I want to do is I want to get what that simplifies to on the inside. So 1 plus 0.01 is 1.01. And now I got to punch that into decimals here. So 1.01 to the 18th, and then I'll times it by 300. So and again, just to walk you through, we did 0.12 divided by 12. And then we had 1 plus that 0.01. That was so that's in our parentheses, 1.01. To the 12 times 1.5, which is 18. And that gives you 1.96147. Blah, blah, blah. Again, don't round it off till the very end. You don't want to have what's called rounding error. So try not to round anything until the end. So now I'm going to go answer times, let's see, where's my answer key? Take that whole thing, which is actually more digits than it's showing, times the 300 in front. So 358.84424. Now this is dollars and cents, so we're going to round to the nearest hundredth. So we end up with $358.81. Now let's do a completely different scenario. This one is you have a person borrowing $500 initially, and after 3 months pays off the loan of $5227.5. So the amount that you pay off at the end is principal plus interest. And if you remember, simple interest is just principal times rate times time. So the amount they pay off after 3 months is $5227.5. They borrowed $5,100, so they're paying off the $5,100 plus the interest, PRT, right? Principal is $5,100. We don't know the interest rate. We're trying to solve that. We paid it off in 3 months. This is our time in years. Well, 3 months over 12 months is a fourth of a year, 0.25 years, right? 0.25. So we got 5,100 plus, now 5,100 times 0.25 is 1275. And let's solve for R. Divide by 1275 to solve for R. 1275. R equals 0.10. In other words, 10%. 0.10 is 10%. So this person was charged a 10% interest rate, right? Based on the math here. Now another scenario is if we take this compound interest formula and we run the compoundings as n goes to infinity, it's called continuous compounding, you end up with this formula, PE to the RT. So let's do that first scenario. The first scenario, we had a compounding monthly. So we had to use this formula, right? But this one, it says it's compounding continuously. So I got to use A equals PE to the RT instead, continuous compounding. We're still putting in $300 up front. We're still getting 12%, and we're still doing it for 1.5 years. Now let's go ahead and punch that in. I should say that's 300 e to the 18, right? That's what we're punching in. You could do this all at once too, 300 e to the 18. Oh, I'm sorry, I did that wrong. That is 0.12 times 1.5, that's 0.18. Sorry about that. 0.18, no. Go up there, there we go, 0.18, there it is. 359.1652. So after, with continuous compounding, we have $359.17, right? The continuous compounding scenario. All right, well, let's do a scenario where in this one, we've got determine the rate that represents the better deal. Is a bank that offers 9% compounded quarterly a better deal, or a little bit higher interest rate, 9.25%, but I only compound annually? Which one's a better deal? Well, let's figure it out. Let's do a scenario. Let's just say we put in $1,000 up front, and then we do it for 1 year. And let's figure out who's the better deal. You could do it for any P and any time T. As long as it's the same for both scenarios, the math will tell you who's the better deal. So we're putting in $1,000. This is 9%, so 0.09. This is compounded quarterly, so 4 times a year. Compounded quarterly, we're doing it for 1 year. And let's go ahead, you know what, we'll just do this whole thing at once. So we got 1,000 times 1 plus 0.09 over 4 to the, let's see, it was 4 times 1 year. So 1,093.08. 1,093.08. That's how much money we'd have at the end of 1 year. All right, let's do the other scenario over here. This time we're still putting in 1,000, but this time it's a little higher interest rate, 0.0925, but it's only compounded once a year. So n is 1, time is 1. Now let's punch this scenario in. $1,092.50. So who's the better deal? One gives us more money. It looks like a little bit lower interest rate, but I want it to compound quarterly for me, right? In this scenario, that's the best deal. So our next topic here is a great way to compare scenarios as well. It's called the effective interest rate. It was kind of like this up here. It was giving us 9%, but it was quarterly. What's actually is an effective interest rate of more than 9% annually. In other words, the effective interest rate is doing the math on what the simple interest rate would be over 1 year. Right? That's what the effective interest rate is. So we're going to go ahead and use that. What's the effective interest rate? Well, if I have something that gives me 24%, 0.24, and it's compounded quarterly, so n is 4, what would this give me? What's my effective interest rate? So 1 plus 0.24 over 4 to the 4 minus 1. And then this whole thing minus 1. So 0.26248. In other words, now convert it to a decimal. So move that over a couple. 26.248%. That's the annual simple interest rate, right? That's what's called the effective interest rate. Because you're actually getting more than 24% per year, aren't you? Because this thing is kicking you out a little bit of interest every quarter, right? It's breaking that up so it ends up compounding on each time that it's kicking you out that interest. What rate of interest compounded annually is required to double an investment in 9 years. Okay, so I want to double my investment. I want to double P. That's what I want to end up with. And want to do it in 9 years. I'm compounding annually, and I'm solving for R. So 2P equals P. 1 plus R over 1 is R to the 9th. Divide. Let's get rid of this P on both sides. So we got 2 equals 1 plus R to the 9th. Now we got to undo to the 9th power, right? So how do I undo it to the 9th power? I got to take the 9th root on both sides. So I got 9th root of 2 equals 1 plus R now. So 1 plus R equals the 9th root of 2. Subtract 1 on both sides. So it's the 9th root of 2 minus 1. So 2 to the 1/9, you can punch it in this way, minus 1. Or 0.0801, which is 8.01%. So if you have 8.01% with an annual compound, you'll double your investment in 9 years. That's what this is saying, right? All right, our last scenario. What would a $90,000 house cost? Boy, it'd be nice to have a $90,000 house. Cost 10 years from now. if homes appreciate 4% annually, compounding annually. So we can use that compound formula on this as well. So we have an initial, what's it cost at the end? What's the amount it costs at the end? $90,000 house. What's it worth in 10 years? If it goes up 4% a year compounded annually, so N is 1, and we're trying to figure it out for T being 10. And let's punch that in. So 1.04 to the 10th times 90,000. We'll just do it all at once. 90,000 times 1.04 to the 10th. To the 10th. 133,221. 6. We'll round that to the nearest cent. So if homes go up 4% over the next 10 years, that $90,000 home will be worth $133,221.99. Thanks so much for watching. I hope that helps. See you guys next time.